Okay, so the continuous random variable x has a probability distribution of f of x is equal to 0.1x for values of x that's greater than or equal to 0 but less than 2, and kx times 8 minus x for the values of x that are greater than or equal to 2 but less than 4, and a for values of x greater than or equal to 4 but less than 6, and 0 for values that are not in this domain. Okay, so where k and a are constants, so that k and a are both constants. So it is known that the probability of the random variable x is less than 4 is equal to 31 over 45. So, but as we know that the sum of the areas within this domain should be equal to 1, right? Because that is the sum of the probability. So, but here, since it only takes up from 0 to 4, okay, the probability is 31 over 45. So, the task is to find the exact value of k. Okay, so we will use this given area, okay, as the sum of these two areas. Okay, so we will be using integration. So we integrate 0.1x from 0 to 2 plus the integral of kx times 8 minus x from 2 to 4. So the area is equal to 31 over 45. Then by using integration, so we have here 0.1x squared over 2 from 0 to 2 plus, so I just distributed kx to 8 and minus 8 minus x, so we have 8kx squared over 2 minus kx cubed over 3 by integration from 2 to 4, again still equal to 31 over 45. Then simplifying, okay, so this part here to 12kx squared minus kx cubed over 3. Then substitute the definite by definite integral, substitute the limits. So substitute 2 to x squared, we got it here, 0.1 times 2 squared over 2 minus substitute 0 to x, so this is 0. Okay, plus this one, substitute the limits, so substitute 4 first. So you have 12k times 4 squared minus k times 4 cubed over 3 minus substitute 2 to x, so we have 12k times 2 squared minus k times 2 cubed over 3. Okay, and this should be equal to 31 over 45 still. Okay, simplifying this, we have 0.2, and simplifying this part gives us 88k over 3, which is again equal to 31 over 45. So 0.2 in fraction is 1/5, so adding it to 88k over 3 will give us 3 plus 440k over 15, which is equal to 31 over 45. Then solving for k, we have here k is equal to 1 over 60. So the second part here is to solve for the value of a. Okay, so since the area for x is equal, or for x is less than 4 is 31 over 45 from the first part, and the area for x is greater than or equal to 4, so the area for x is greater than or equal to 4 but less than 6 is equal to 1 minus 31 over 45. So that's like the complement of this one. So considering that f of x is equal to a, then the graph is a horizontal line at y is equal to a. So just like this one. So this is the graph. So from 4 to 6. So therefore this area here is equivalent to 2 times a, because the length from 4 to 6 is 2, and then the height is a. So since this is a regular polygon, we can find the area by multiplying these two sides, 2 times a. Okay, thus 2a, which is the area of this polygon here, is equivalent to this area, 1 minus 31 over 45. So simplifying, 2a is equal to 14 over 45, and then a is equal to 14 over 90, which is simplified to 7 over 45. Okay, and then the last part, solve for the probability of x being greater than or equal to 0 but less than or equal to 5.5. So as we know that this a here has a domain from 4 to 6, but what we need is just up to 5.5. So we know from 0 to 4 it's already equal to 31 over 45, and 4 to 6 is 7 over 45. So, but that's not what we need. So, uh, we solve for the probability of x from 4 to 5.5. So, if 5.5 is somewhere here, okay, the length here will be just 1.5, and then this is a. So, since we know from the previous part, a is equal to 7 over 45, okay, this one, and then this length here from 4 to 5.5 is just 1.5, okay, and then 1.5 converted to fraction is 3 over 2, so multiplying it, we have 21 over 90, adding it to 31 over 45 here. Therefore, the area or the probability of x being greater than or equal to 0 but less than or equal to 5.5 is equal to 83 over 90.